welcome back. Ready to dive into some serious SQL Server wisdom today.
Always ready for a deep dive.
Awesome. So we're cracking open 100 SQL Server mistakes and how to avoid them. This fantastic book by Peter Carter.
Oh, that's a good one. A classic.
It is. But we're not going to tackle all 100 mistakes today.
Definitely not. 100's a big number.
Right. So we're focusing on the ones that I think will resonate most if you're maybe an app developer who's suddenly, been thrust into this world of bigger databases.
Makes sense. So kind of like a survival guide for the newly initiated DBA.
Exactly. Or even, for seasoned pros, a good refresher on those sneaky pitfalls we can all fall into sometimes.
Yeah, those gotchas can get anyone.
Exactly. So the first mistake Carter dives into is, it's a big one, neglecting database architecture.
Yeah. The temptation to just jump right into building, especially when you're in a fast-paced environment.
Oh, yeah, especially in the agile world, right? Move fast and break things.
Right. But with databases, you really don't want to be breaking things because those breaks can be a real pain to fix.
A real pain, yeah. Costly. So the book argues that even with Agile, you've got to have some kind of architectural plan from the get-go.
It's like building a house. Would you start laying bricks without a blueprint?
Probably not a good idea. End up with some interesting rooms, maybe.
More like a structural nightmare, I'd say. You might end up with walls that don't align, rooms that are too small, a foundation that can't handle the weight.
Yeah. And in database terms, that translates to all sorts of problems, like data inconsistencies.
Oh, yeah. Data redundancy nightmares.
Performance bottlenecks, all those fun things.
Fun for nobody.
Nope. And Carter gives some really vivid examples of what not to do. Like, imagine you're building a database for an e-commerce site, and you just lump all your customer data into one giant table.
The everything but the kitchen sink approach to database design.
Right. Seems convenient at first, but then let's say you need to update a customer's address.
You got to change it in multiple places.
Exactly. So you increase the risk of errors. You've got inconsistencies all over the place. It's just a mess.
And that's where normalization comes in to save the day. It's all about breaking down those giant, unwieldy tables into smaller, more focused ones with, clear relationships between them.
So it's like instead of having one massive customer table, you'd have separate tables for customer info, addresses, orders, that kind of thing.
Exactly. Each table has a primary key to uniquely identify each record, and you use foreign keys to link related records across different tables.
And this structured approach, it's not just about data integrity, is it? It actually makes your database more efficient too, right?
Absolutely. You avoid data duplication, reduce storage space, and your queries run faster because you're only accessing the data you need.
Gotcha. So it's a win-win. Okay, normalization. That's one to remember, folks. Now, mistake number 2, using wide primary keys. This one caught my eye because I've been hearing a lot about GIDs lately.
GIDs, yeah. They have their place, for sure.
Right. They seem pretty popular, but Carter's not a huge fan of them for primary keys.
Yeah, particularly when it comes to clustered indexes. They can cause a bit of a performance drag.
Now, just to remind everyone, a clustered index, that's basically how the data is physically organized on disk, right?
That's a good way to put it. Like, think of a phone book sorted alphabetically by last name.
Right. So why are GIDs a problem in this context?
Well, GIDs are much wider than your typical integer primary key. So that means your clustered index gets bulkier, less efficient, like trying to cram a whole bunch of, oversized luggage into a compact car.
Okay, I see. It's not going to fit very well. You're going to have stuff sticking out everywhere.
Exactly.
Yeah.
And it's going to be a lot harder to find what you need. So instead of that nice, compact, sequentially ordered index that you get with an integer key.
You end up with a more fragmented index, scattered across multiple pages on disk.
Exactly. Which makes lookup slower, like flipping through more pages in that phone book.
Okay, makes sense. And to make matters worse, GIDs are randomly generated, right?
Right, which increases the chances of index fragmentation even more. Every time you insert a new row, SQL Server has to find a place for it in the index. And with UDs, it's more likely to end up on a different page.
So more scattered data, slower retrieval times. Not ideal.
Not ideal at all.
So what's the solution? Do we banish GUIDs altogether?
No, not necessarily. If you need GUIDs for other purposes, like integrating with external systems, that's perfectly fine. But for the clustered index, the primary key, stick with a simple integer. Keeps things nice and tidy.
Oh, I see. So use the right tool for the job.
Well,
GUIDs might be great in other scenarios, but for clustered indexes, integer key all the way.
makes sense to me.
Right. Okay, this next one's a bit a bit scary to me, honestly. It's about omitting foreign keys for convenience. And I was always taught that foreign keys, those are like the guardians of data integrity.
I hear you. They're absolutely crucial for enforcing referential integrity, ensuring those relationships between your tables are maintained.
Right, right. But the book, it explores those, those situations where a DBA might be tempted to skip them. Like imagine you've got a massive table, millions of records,
Yeah, yeah.
and you need to update something like a purchase order number that has a foreign key constraint.
And checking millions of records to validate that update. Yeah, that can take a while.
And some folks might see that as a performance bottleneck.
It's tempting to just bypass it thinking, oh, it'll be fine.
But the risks, they're just too high. Right? What could go wrong if you skip the foreign key check?
Oh, all sorts of chaos. Imagine a glitch happens during the update. What if it doesn't propagate correctly? You can end up with orders linked to non-existent purchase orders, payments going to the wrong places, inventory records completely out of sync.
Okay, that sounds like a recipe for disaster.
It is. It's like removing the safety net from a high-wire act.
Yeah, no thank you. I'd much rather have a slightly slower update than a database full of inconsistencies and errors.
It's all about weighing the risks and benefits. And in most cases, the risk of data corruption far outweighs any minor performance gains you might squeeze out by skipping foreign keys.
They're like our insurance policy, really.
I like that.
Yeah,
You're guardians of data integrity, protecting you from those sleepless nights.
definitely worth the peace of mind. Okay, let's dive into some T-SQL development territory. This first one's a bit embarrassing to admit, but I've been guilty of this one myself. Using select. It's just so convenient, especially when you're just exploring data or writing a quick query.
Oh, I totally get it. It's tempting, for sure.
Yeah.
But in a production environment, especially with larger databases and applications, select, well, it can create more problems than it solves.
Yeah, yeah. The book kind of slams it for performance issues, code maintenance headaches, and readability problems. Let's unpack those a bit. Starting with performance. Why is select such a performance killer?
Think of it this way. You have a table with, say, 50 columns, but you only need data from, like, 5 of them.
Yeah.
Using select forces SQL Server to fetch all 50 columns, even the ones you don't need.
Oh, okay. So it's like ordering a 5-course meal when all you wanted was the appetizer.
Haha, exactly. You're paying for and consuming way more than you actually need.
And all that extra data, it's got to travel from the database server to your application.
Right. Consumes more network bandwidth, potentially slows down your application's response time.
So even if I have like a blazing fast network, select can still bog down my database server.
It can, because SQL Server has to work harder to process and retrieve all those extra columns, even if they're not being used. More CPU usage, slower query execution times.
Okay, so not just a network issue, it's a server-side issue too.
Gotcha.
And what about code maintenance? How does select make that harder?
Imagine you have a stored procedure that uses select to fetch data from a table. Then, let's say down the line, you add a new column to that table. Your stored procedure, it's blindly fetching all columns. So it might break or produce unexpected results because now it's trying to process this new column that it wasn't designed to handle.
So if you're explicit about which columns you need, it's kind of like future-proofing your code a little bit.
Exactly. It's
Yeah.
more robust, less likely to break when the database schema changes.
And easier to understand too, right?
Much easier.
Yeah.
If someone else is looking at your code, or even if you come back to it months later, it's way more clear what's going on if the query specifically lists the columns it's fetching.
Right, right. Select is like, it's like writing a recipe that just says throw everything in a pot. Not very helpful.
Not at all. Be specific.
Okay, lesson learned. No more lazy select for me.
Right.
Now, this next mistake, I wouldn't have even thought of it as a problem, honestly. Ordering data unnecessarily. Isn't ordering data a good thing? Makes it easier to read, understand, all that?
It can be, but only when it's truly necessary. Adding an order by Y clause to every query, especially when you're dealing with large data sets, can really bog things down.
Oh, really? I mean, I get that sorting millions of rows, that's going to take some processing power.
Oh yeah, lots of behind-the-scenes work for SQL Server. Comparing values, moving data around in memory. Might even involve writing temporary data to disk.
So if I'm just pulling data to, I don't know, display in a grid or something, and the application can handle the sorting.
Let the application handle it. No need to burden the database server with that extra step.
Makes sense. But what if I add an index to support that order by Y? Wouldn't that make it faster?
It might make that specific query faster, but it adds overhead to other operations. Inserts, updates, deletes, all that. Remember, every index needs maintenance and storage space.
So it's a trade-off. Okay, gotcha. Be mindful of when ordering is truly essential. If it's just for presentation, let the application handle it. Makes sense. Now, this next one, it's kind of related. Using distinct unnecessarily, which, I mean, it's about removing duplicate rows, right?
Right. And that seems like a good thing.
Yeah. Keeps things clean.
It does. But distinct, it comes with a performance cost. SQL Server has to do extra work to identify and remove those duplicates. And for large tables, that can be quite resource intensive.
Ah, okay. So if you don't absolutely need to eliminate those duplicates.
Maybe there's a more efficient approach.
Right, right. And the book, it actually suggests some alternatives, like using group by Y or row number.
Yeah, those can be more efficient depending on what you're trying to achieve.
It's amazing how there are, like, multiple ways to do the same thing in SQL. But some ways are definitely more efficient than others.
It's all about choosing the right tool for the job, understanding the nuances of the language. Sometimes, the need for distinct might even be a symptom of a deeper problem.
Oh, like what?
Like maybe there's too much data duplication because your tables aren't properly normalized.
Ah, so it's like if you're constantly having to use distinct to get the unique values you need.
It might be a sign that you need to revisit your database structure. Make sure you're not storing redundant data.
Gotcha, gotcha. So distinct can be a valuable tool, but it's important to use it wisely. And always consider if there might be more efficient alternatives. Speaking of unnecessary operations, this next mistake is it's one that I always hear about, using union when not needed. I have to admit, I'm a bit fuzzy on the difference between union and union all.
Yeah, it can be a bit confusing. Both are used to combine the results of multiple select statements.
Right.
But union, it removes duplicate rows from the combined results set, while union all just lumps everything together, duplicates and all.
Okay, so if I know there won't be any duplicates, or if I don't care about duplicates.
Union all is your friend. It's faster, more efficient.
So union is kind of like it's like having a bouncer at the door of your query, making sure no one gets in twice.
I like that.
But if you don't need a bouncer,
Just let everyone in.
makes sense. Okay, let's talk about this next one, which I know is a bit of a hot topic among SQL folks. Overusing cursors. Now, I understand that cursors are generally frowned upon, but honestly, I'm not entirely sure why. Can you shed some light on that for me?
Sure. Imagine you're a chef with a whole team of sous chefs ready to work. Cursors are like telling each chef to work on one ingredient at a time, bring it to you for approval, then move on to the next ingredient.
Okay, that sounds incredibly inefficient. What's wrong with that approach?
It's very serial, one step at a time.
Oh.
But SQL Server, it's optimized for set-based operations, where it can work on large chunks of data simultaneously.
So it's like having all your sous chefs working in parallel, right?
Exactly. Getting things done much faster.
Makes sense.
But cursors, they force SQL Server to process data row by row, like having one chef doing everything, one tiny step at a time.
So it's like putting a handbrake on a race car.
Pretty much.
Okay, I see why they get a bad rap. But are there ever situations where a cursor might be the right choice?
Maybe. The book gives an example of calculating stock levels for each product in a table. A developer might think, okay, I'll loop through each product with a cursor, calculate the stock level.
Right.
But there's almost always a better way to do it using set-based operations. SQL Server's got all these powerful tools. Aggregates, joins, subqueries. You can perform complex calculations on whole sets of data at once.
So it's about leveraging the power of the SQL engine, right? Not tying its hands with those slow row-by-row operations.
Exactly. And the performance difference. It can be night and day.
Okay, I'm convinced. Cursors, use them sparingly, if at all. Now, this next mistake is a bit more nuanced. Deleting large volumes in a single transaction. I get that deleting tons of data can impact performance, but what's the big deal about doing it in a single transaction?
It all boils down to the transaction log.
Ah, okay.
When you do anything in SQL Server, insert, update, delete data, those changes are first written to the transaction log.
Right, that's like the database's diary, right?
Perfect analogy. So if you delete like millions of rows in one giant transaction,
That log is going to get huge.
huge, and that can cause problems. The log can eat up disk space, slow down your database, and make restoring from backups a real pain.
So break it down into smaller batches.
Exactly. Commit each batch separately. Give the transaction log a chance to breathe.
Okay. That makes sense. Batching those delete operations is a simple but effective way to keep things running smoothly.
Absolutely. It's often those small details that make a big difference in the long run.
All right, we've tackled design and T-SQL. Are you ready to get into some backups and recovery?
Oh, yeah. Always important.
This is where things get real serious, right? Like, oh no, I dropped the production database serious.
No kidding. And the first mistake Carter highlights is it's ignoring backups as part of a security posture.
Okay. I think a lot of people, maybe even myself sometimes, you think of backups as mainly for disaster recovery, like, a fire, a flood, takes out your server room, that kind of thing.
It's a common thought, yeah.
Yeah.
But it's a dangerous one. Backups, they're way more than just a safety net for those, big natural disasters.
Oh, okay. So what else? What other threats are we talking about?
Data corruption, accidental deletions,
Hmm.
and the one that's keeping everyone up at night, ransomware attacks.
Ransomware, yeah. That's a whole other level of scary.
It is. They can just cripple your systems, hold your data hostage.
And demand those crazy ransoms to get it back.
Exactly. But that's where a solid backup strategy can really save the day.
So it's not just about recovering from technical failures. It's about business resilience.
Exactly.
Yeah.
Like having an insurance policy that covers, not just accidents, but theft and vandalism,
Oh,
too.
right, right. Okay, that makes sense. Now, this brings us to something that I think a lot of people get confused about. High availability versus disaster recovery. HA and DR.
Yeah, those terms get thrown around a lot,
Oh.
sometimes interchangeably.
Right. But they're not quite the same thing, are they?
Not quite. High availability. That's all about minimizing downtime, making sure your systems keep running, even if individual components fail.
So it's like having a spare tire in your car. Get a flat, you swap it out, and you're back on the road.
Perfect analogy.
But disaster recovery, that's for when things go really, really wrong.
Right. Exactly. It's about recovering from a major incident that could potentially wipe out your whole primary data center.
Okay, so it's more like having a backup plan for when your car gets totaled.
That's it. You need more than just a spare tire in that situation.
You need a whole new car. And probably a good lawyer.
Uh-huh, maybe. But the point is, HA and DR, they serve different purposes. They need different approaches.
Right. Don't rely on your spare tire to get you home after a major crash.
Exactly. Now, the book dives into specific SQL Server solutions for both, like availability groups for HA,
Right.
log shipping for DR.
Oh, right. Availability groups, those are great for maintaining uptime within the same data center, right?
Exactly. Automatic failover to a secondary server if the primary one goes down.
Seamless.
Seamless, yeah. But log shipping, that's more about getting your database up and running at a different location, like if your primary site is completely toast.
Exactly. So it's crucial to choose the right tool for the job. And that leads us to mistake #12, not architecting for requirements.
Okay. What does that mean exactly?
It's about, sometimes people fall into the trap of thinking more availability is always better. They aim for that mythical 5 nines of uptime.
5 nines. So that's 99.999% availability.
That's it. But without really thinking about the costs, the complexity involved.
Yeah, I can imagine that gets pretty expensive pretty quickly. Like building a fortress for your data when all you really need is a sturdy fence.
It's about finding the right balance,
Yeah.
right, between cost and risk.
Right. So what questions should we be asking ourselves?
What level of downtime can your business actually handle? What are the consequences of an outage? How much are you willing to spend to achieve a specific level of availability? Okay, so don't over-engineer for a level of availability that you don't actually need.
Right. And speaking of making sure your solutions actually work, this brings us to mistake #13. Not testing your DR strategy.
Yes. The classic set it and forget it mentality. That doesn't really work for disaster recovery, does it?
Not at all. Having a plan on paper is one thing. Making sure it actually works in practice is another.
Yeah. It's like having a fire escape plan but never actually practicing it.
Right. When the alarm goes off, everyone's going to be running around in a panic.
This plan goes out the window.
Exactly. So with DR, you got to test it regularly. Make sure it really works when you need it most.
So those tests, they shouldn't just be about validating the technical stuff, right? Like making sure the backups are working, the servers can talk to each other, all that.
Right. You also want to involve users in those tests. Make sure the applications, the data, it's all accessible and performing well from their perspective.
Oh, that's a good point. Because what good is a technically perfect recovery if the users can't actually, use the systems?
Exactly. It's got to work for everyone.
Right. So testing is not just a technical exercise. It's about It's about building a culture of preparedness, right?
That's a good way to put it. Make sure everyone knows what to do when the what hits the fan.
All right, let's shift gears a bit and talk about something that's, well, it's more important now than ever. Security.
Absolutely. Can't have a conversation about databases without talking about security these days.
Nope. And the first mistake Carter highlights is it's one that I think a lot of organizations are probably guilty of, not implementing least privilege.
Ah, yes. The principle of least privilege.
Right. So what does that actually mean in the context of SQL Server?
It means give users and applications only the permissions they absolutely need to do their jobs. No more, no less.
Okay. So it's not just about being stingy with access.
Right. It's about reducing risk.
Mm.
If a user account gets compromised, the attacker has access to only what they were granted.
So it's like giving someone a key to their office, but not to the entire building.
Exactly. You limit the potential damage.
Right, right. Makes sense. Okay, now let's talk about a specific account that often gets people into trouble. The dreaded say account. The book talks about not disabling the say account, and I gotta say, this one always makes me a little nervous.
The say account. Yeah, that's a powerful one. System administrator account. It has unlimited power in SQL Server.
Unlimited power, huh?
Pretty much. It can do anything. So if it falls into the wrong hands, well, it's not a good situation.
Not good at all. So what's the best practice here? Just disable it completely.
Ideally, yes. Disabling or renaming it is one of the first things you should do to secure your SQL Server instance.
But what if I need to, do some administrative tasks that require those say level permissions?
Instead of relying on the SAD account, create separate user accounts for those admin tasks and grant them only the specific permissions they need for that task.
Okay. So it's a more granular approach to security, right? Instead of having this one super user account, you create a system with multiple accounts, each with limited privileges.
Exactly. It's a much more secure approach. Reduces the risk of a single point of failure.
Right. Makes a lot of sense. Now, this next mistake is one that I've always heard is a bad idea. Enabling XPCMD shell. Honestly, I don't fully understand what it is or why it's so dangerous.
So XPCMD shell is an extended stored procedure. It lets you execute operating system commands from within SQL Server.
Oh, okay. And why is that a problem?
Well, imagine an attacker gets access to your SQL Server instance, and XPCMD shell is enabled. They could potentially run any command they want on the underlying operating system.
Oh, wow. So it's like giving them a backdoor into your server.
Exactly. They could steal data, install malware, who knows what.
Not good. Not good at all. So the takeaway here is just don't enable XPCMD shell. Right.
Unless you have a very, very specific reason,
Yeah.
and you've carefully weighed the risks and taken all the necessary precautions, it's best to leave it disabled.
Okay. Noted. Now let's move on to something that's crucial for maintaining accountability and detecting any suspicious activity. Auditing.
Auditing is like having a security camera for your database.
Mm-hmm.
It records who did what, when they did it, what data they accessed.
Okay, yeah. Sounds like a pretty important tool. But the book, it highlights a mistake that a lot of organizations might be making, not implementing auditing of administrative activity.
Right. A lot of organizations assume that, their database administrators are trustworthy.
Yeah. You want to trust the people who have the keys to the kingdom, so to speak.
But even with trusted admins, auditing is still crucial for several reasons.
Okay, I'm listening. Convince me. Why is it so important to audit even those trusted admins?
Well, for one, it provides accountability.
Mm-hmm.
Even the best DBAs, they're human, right? They can make mistakes. An audit trail can help you figure out, pinpoint the source of problems. Could be a configuration error, a script gone rogue, or even unintended consequences from legitimate actions.
So it's like having a black box recorder for your database. If something goes wrong, you can go back, analyze the logs, and figure out what happened.
Exactly. And if, God forbid, there's a security incident, that audit trail, that's gold. Helps you figure out what data was accessed, when, and by who.
Okay, yeah, I see that. So even if you trust your admins having that objective record, it can help you resolve issues, identify areas for improvement, and, respond to those security incidents.
Exactly. And don't forget about compliance. Lots of regulations, especially around sensitive data like healthcare info, financial stuff, they require auditing of admin actions.
Right. So having that audit trail makes it a lot easier to prove you're following the rules.
Exactly. It's like It's like having all your receipts organized when the tax man comes knocking. You can show him everything's above board.
Love that analogy.
Yeah.
So auditing, not just about catching bad guys, it's about gaining visibility, right? Seeing how the database is being used.
Absolutely. It's about being proactive, spotting potential issues before they become big problems.
Now, the book, it also talks about non-repudiation.
Ah, yes. Non-repudiation.
What is that exactly? And why is it so important in the context of auditing?
Non-repudiation means you can prove a specific action was taken by a specific user, and they can't deny it. Think of it like a digital signature on a document.
Okay, so if someone, let's say, deletes some sensitive data or makes an unauthorized change, you've got that audit log. You can prove who did it, when they did it, even if they try to say, nope, wasn't me.
Exactly. It's about having that undeniable evidence.
Makes sense. But what about the audit logs themselves? How do you make sure that someone can't just go in and tamper with them, delete stuff, change things around to cover their tracks?
Great question. And it's a valid concern. There are techniques to protect the integrity of those logs. One way is to write them to a separate system, like the Windows security log, more secure than keeping them in the database itself.
Right. So it's kind of like having a separate vault for your most precious jewels, protected by extra layers of security.
Perfect analogy.
Mm.
Another technique is using something called cryptographic hashing. It basically creates a digital fingerprint of the log data. If someone messes with the logs, the hash changes, and you know something's up.
Ah, okay. So you're essentially creating a tamper-proof system for those logs.
Exactly. You need to be confident that the audit trail is accurate and reliable.
Makes sense. Makes a lot of sense. Well, I feel like we've covered a ton of ground in this deep dive. We've gone from database design to T-SQL pitfalls to backups, recovery, and now security. My brain is full.
Lots to think about, that's for sure. But it's all essential knowledge if you're working with SQL Server.
Absolutely. And the good news is these mistakes, they're common, but they're often preventable, right?
Absolutely. It's all about understanding the risks, implementing those best practices, and staying vigilant.
Right. So to our listeners out there, we want to hear from you. What are your biggest takeaways? What resonated with you the most? What challenges are you facing in your SQL Server world? Share your thoughts with us. We love hearing from you. Until next time, happy querying.